Okay, so this is also indefinite integral. So we are still in integration. Now this one is different. So let's see how you can approach these types of questions. Okay, so when you are having a natural log x and then over x dx, how can you deal with that one? Okay, so this is also simple, but the method you need to use is substitution method. Okay, substitution method. Okay, so this is the method you need to use. Okay, so here what you need to do is to let u be the natural log. Okay, be the natural log x. So let's now differentiate in x. So du with respect to x, u with respect to x. So du will be what? 1 over x. Remember, if you want to differentiate, we are talking about integration, but it involves integration. Okay, that's why it is called u substitution. Okay, so if you're having something, you don't have to go direct to integration. You have to involve the what? Differentiation. So in x over x, you have to use substitution method. So in that case, let u is equal to in x. So du will be what? 1 over x. However, I love that 1 over x. If you are having a function, if you are taught to differentiate the function, let's say d dx of in having a function, it can be in of a function, any function, natural log of any function. Okay, so it will be equal to that function you differentiate. You differentiate that function, which means dy dx of that function over that same function without differentiating. Okay, that's how it is. For example, you have in x, okay, in function. So now the function here is x. What you need to do is what? You differentiate x. So you differentiate x. If you differentiate x is 1 minus 1, 1 times x. So it will be just x to the power 0, which is 1, over in x without what? Differentiating. That's why we got what? 1 over x what? Dx. Okay, I'm sure you have gotten the point. Okay, that's how it is. So imagine if you have in x squared, what would you do if you are taught to differentiate? So dy dx or f prime, or like this prime, it also means dy dx. If you say y prime, it means dy dx. Okay, if you say a function prime, it means the same, you are differentiating. So dy dx will be equal to, you do what? Differentiate x to the power 2, it will be what? 2x over what? This you just see, you just get this without differentiating, x squared, right? So that's what we are trying to do. So here in our case, we have what? We have made in x over x, we have u is equal to in x. So du will be what? 1 over x dx. So we want to make dx the subject. So you divide 1 over x, you divide 1 over x. So dx will be what? X du. Okay, if you don't know how I've arrived at x du, remember we are saying du divide by 1 over x, right? So in that case, it means du divide by 1 over x, such that when you are dividing, it will change to multiplication, of which x will be on top, 1 at the bottom. So here if you multiply du times x, it will be x du. That's why I said I've written x du. Okay. So dx is x du. So in this case, we are going to replace. Remember, u is equal to in x. So in that case, we are going to say, where there is in x there, we are going to put what? U over x. Okay? Over x. And then, where there is dx, dx is equal to what? X du. So we are going to put what? X du. So it is multiplying. Remember, this x divided by x will what? Cancel, which is just 1. So we are going to remain with what? U du. Now let's integrate since we have simplified. So it is what? U to the power 1 plus 1 over 1 plus 1. Remember, it is indefinite, so it is plus constant. So in that case, it is what? U squared over 2 plus c. So in that case, what we need to do is, let's see, u to the power 1 plus 1, it is u squared, 1 plus 1, then it is over 2, right? Over 2 plus c. So what is our u? In x, and it is having squared. So in x, okay, in x squared over 2 plus c, right? So this is what we are having. This is what we are having. Okay, that's how you approach this one. Okay, so let's see the second one. We are given we have exponential now. We are done with natural log example for substitution method. So we are on the natural log x e to the power 2x dx. This is also you have to use, in this case, you can use substitution and also integration by parts. Integration by parts. Okay. So under integration by parts, we are going to say the key is if you have got, for example, the integral of u dv is uv minus the integral of v du. Okay, so this is the key. Okay, so I'm going to transform this x exponential to the power 2x dx into this form. U dv is equal to uv minus v du, the integral. So here what we need to do is, remember u dv is what we are having there, x e to the power 2x. Okay, so our u, let x be our u. Okay, let x be our u. So u will be equal to what? X. Okay, so where there is u, where there is x, you will put u, right? So our u will be x. So our x will be the u. Okay, so let's differentiate. So in that case, du, okay, u with respect to x, which means du will be equal to dx, because if you differentiate x is just 1, so 1 dx, okay, which is just dx. 1 dx, which is just dx. Okay, we differentiate just 1, okay, which is just dx. So our dv will be equal to e to the power what? 2x d what? dx. So v with respect to what? E to the power x, which is x. So v will be equal to, when you are differentiating the exponents, what you need to do is to differentiate the power and then you find the inverse of that power. Okay, the inverse of that power. So we are going to have, for example, if you have got, if you differentiate 2x, okay, the answer will be what? Will be, the method is nax n minus 1, right? Now the n is a power. In our case, our power is what? 1, right? So 1 times 2, it will just be what? So it is 1. A is the first number, which is 2 there, 2. And then x is just x, in case you don't know. N is a power, which is 1, and then minus 1, which is just introduced as 1. So 1 times 2, it is 2. And then x there, it is just x, and then to the power 0. Anything less to the power 0, n number, it is just 1. So 2 times 1, it is just 2. So this is what we need to do. So if you differentiate 2x, you just get what? 2, right? You just get what? 2. So the inverse of 2, it will be now 1 over 2, because it is just 2 over 1 naturally, right? Though the 1 is not indicated. So in that case, that 1 will go on top. Now it will be 1 over 2. So that's how you do with the what? When you're differentiating the what? The exponents. So, for example, if you have got exponent squared, right? When you differentiate, it will be what? This x you differentiate, you are going to get 1. So it is 1 over 1, which is just like that. That's why it comes just like this. Even if you are you have differentiated the exponent. Okay, so in our case, but this one, it is 2. So it will be 1 over 2. So it is 1 over 2 e to the power 2x. Okay, it will just come like that. Okay, so that's what we have gotten. We now have u, v, and du also dv, right? dv. Okay, so in our case, the u dv, integral u dv, is what we have as the xe to the power 2x what? dx is equal to, this is the equals u. U is equal to what? X. This u is x. What about v? Our v is what? We are multiplying, right? Multiplying, so we have to multiply. So we are multiplying 1 over 2 e to the power 2x. Okay. That is our v, right? That is our v. And then minus, okay, v, our v is what? Minus the integral, our v is what? 1 over 2 e to the power 2x du. Our du is what? dx. So where there is dx, we put just what? du. So du is equal to dx. Okay, du is equal to dx. So in that case, we are going to have, when you multiply this, half will come here in front. So 2x exponential to the power 2x So 1 over 2x exponent 2 to the power x exponent 2 to the power x. So 1 over 2x e exponent 2 to the power x minus this half will come here, 1 over 2 e, okay? So if it comes in front, you are just going to remain with what? E to the power what? Here we have already so what we have is this. So we are going to remain with 1 over 2 exponent 2 to the power x, right, du. Okay, that's what we are having. Okay, so in that case it is going to be 1 over 2 x e to the power 2x minus 1 over 2. So if you integrate what we have here, it is going to be 1 over 2 e to the power 2x. Again, it has returned like that, plus c. Okay, remember it is indefinite. So in that case, the final answer will be 1 over 2 e to the power 1 over 2x e to the power 2x minus 1 over 4, because 2 times 2, right? So 1 over 4 e to the power 2x plus what? Plus c. But from here, there you can also, you can as well simplify from there. If you like, you are having e to the power 2x, which is common. Let's see how we can simplify. Okay, so you are having, you can leave it there or you can simplify. Okay, you can leave it here or you can simplify. You are having exponent to the power 2 to the power exponent to the power 2x, and then here you are going to have 1 over 2, right? And then you are going to remain with what? X here, okay, minus 1 over 2, okay, 1 over 2, just 1 over 2, right? Yes, just 1 over 2, and then plus c. You can simplify in that way. Okay, you can simplify in that way. Okay, or you can just remain here. Okay, that's how it is. So let's look at the last one now. Let us look at the last one. So, can you try that one? Okay, what method are we going to use under integration? Okay, so this one is x plus 1. It is at the bottom. So what can we do? Okay, so what we have to do here is we have to use u substitution. Okay, substitution method. Okay, u substitution method. Okay, so in our case, we let u be x plus 1. In that case, therefore, the integral of 1 over, so the square root, so x plus 1 is u, so we are going to put u. Okay, that's how you simplify, and then therefore this will be equal to what? Will be equal to 1 over square root. You can just move the square by introducing power 1 over 2. So power 1 over 2 is the same as square root, okay? The person who has written this and this is just the same, okay? So when you remove this, is going to be the square root u. So when you reach this stage, when this one goes on top, it will be what? It will be okay, so if u is equal to x plus 1, so our du will just be dx. So this one, it is just the same as du, okay? And then this one, yeah, du like that. So in that case, we simplify again, it will be u to the power negative 1 over 2 du, okay? 1 over 2 du. Okay, so in that case, we can now do the integration. So which is going to give us u to the power 1 or negative 1 over 2 plus 1 over negative 1 over 2 plus 1 plus c. Don't forget the constant. Once you forget, you get it all wrong. Okay, so when you have negative 1 over 2 plus 1, the common denominator 2, and then it's going to be what? Negative 1 plus 2, which is just going to be 1 over 2. So this one will be u to the power 1 over 2 over 1 over 2 plus c. Okay, we can simplify from there. We can simplify and say, square root u, okay, square root u. Since we are dividing, remember what we said, when you divide by 1, divide by 2, then 2 will be on top, right? 1 will be down. So here you are going to put 2 there, okay? For the sake of the doubting Thomases, we are going to say u to the power 1 over 2 divide 1 over 2, such that u to the power 1 over 2, when you multiply, 2 will come on top and then 1 down. So u to the power 1 over 2 times 2, it will just be 2u to the power 1 over 2. Okay, over 1, which is just the same. So here, 2 will come here. Okay, that 2 will come this side. Okay, so it will be 2u, okay, plus what? C. Okay, so 2 square root, what is our u? We had read x plus 1 to be our u. So it will be x plus 1 plus c. You are done. Okay, I'm sure it is clear. If you have any question, just post the question. We'll do it together.